Okay, let's get started here. So, thank you all for coming. Today
Is it working?
Professor Chandralekha Singh. She's from the University of Pittsburgh. She got her PhD in theoretical condensed matter physics and then has transitioned into physics education research. And her research focuses on identifying problems in terms of how students understand and grasp physics concepts, both at an introductory level and also at higher level quantum mechanics classes and things like that. And she's going to talk about kind of these problems and what are ways pedagogically that these can be addressed. And before I turn the floor over to her, I just want to make an announcement that after this talk, we will have a tea in the Joseph Henry room that's open to everyone, and this is meant to continue this conversation with Professor Singh and just have more of a discussion on these ideas. And I'd also like to thank Professor Jim Olson for rescheduling his class that I heard about to allow him and his students to attend this talk. And so with that, let's all welcome Professor Chandralekha Singh.
Thank you. Thank you so much, Malika. I'm delighted to be here, and I really want to make sure that this is a conversation that you will actually continue even after I've left. So I wanted to start out with this picture that all of you are actually familiar with, right? And in this thing, there are 29 scientists, physicists, and there is only one woman. You can see, Madame Curie there. Why did I show this picture? Why did I think that this picture was relevant? This is how I felt when I went to graduate school and entered my class in 1988 at UC Santa Barbara, right? I was in the PhD program there. I came from India thinking, there are going to be lots of women because America was much more progressive than India. And here I enter the class and I see I'm the only one in a class of 36. So that was not really a good feeling because I immediately got this feeling that I didn't belong there. I started having this self-efficacy problems. Am I good enough to be here? I started having all these issues that I didn't, anticipate because I thought that I was going to be in a class with many other women. But no, I was the only one in a class of 36. And in fact, things haven't changed even today. So this is from only a couple of years ago. And if you look at what a typical group of physicists looks like, it doesn't look that different. So if you really think about your classes, you might say, what really actually, leads to underrepresentation of certain groups? And I'm going to be focusing here mostly on women in physics, even though the same kind of issues are also there for racial and ethnic minority students. And many of the things that I would talk about can actually be, translated even to that group, even though the research study that I'm going to focus on is related to women in physics. So you might say, what are the reasons for their underrepresentation? And people have mentioned a lot of different things, including prior preparation, teaching approaches are maybe not suitable, the socio-cultural norms, the fact that, in our society, maybe the societal norms have certain stereotypes there that actually, dissuade women from coming into physics. Also, if people actually are thinking about coming into physics, do they feel like they belong here? Do they feel like they actually will do well in this discipline? And what is the physics department? What are the physics departments across the country doing, or across the world doing, to really make sure that they feel like they belong? They feel like they can make a contribution, and to make sure that they are mentoring and supporting the people who actually show up there, right? And to get more people who otherwise would not show up. Because I also wanted to say that another research study that we have done relates to women in engineering, and there what we are finding is that women actually always have one grade point, roughly like one grade point, and by one grade point I mean B+ to A-, one grade point above men in all of their math courses, calculus 1, 2, 3, differential equations, linear algebra. Women who show up in engineering, they always score one grade point above men, and even in engineering courses, either they are at the same point as men or they score somewhat better. So somehow a lot of people are dropping out even before they have come into a particular discipline, right? So what are the reasons for their underrepresentation? But again, coming back to this issue of, if there are very few people in a particular class who looks like a particular person in that class, what would they feel like being there, right? So, for example, does your class look like, what does your class look like to a student who's sitting in the third row or something? Does it look very much like that particular picture that we saw, which has only men there and very few women? Can it increase the anxiety of certain students in those kinds of classes? And how might students feel about their potential in such a course? Will the gender, or can the gender or race of the student actually increase the anxiety of the student, right? That's something that I want you to think about. And what do you, and if that's the situation, if that's the way your class looks like, that there are many, most of it looks like they're men and not that many women, or not that many people who are people of color, then by that I mean, like, let's say African Americans or Hispanic students, then would they actually have any anxiety about being there? And what have you done as an instructor, or what are you trying to do as an instructor to bring down their anxiety and make the learning environment, supportive and, congenial to learning for all of the students? So that's the question that I want you to think about throughout this talk. What are you doing? Because one of the issues that is really important here is that there are two sides to any game that you play, right? One is offense and one is defense. And so you are going to be best at offense only if your defenses are straight, right? So if people are having belonging issues, if they are having identity issues, do I have the identity as somebody who's good at physics? If somebody has this intelligence in a mindset issue, am I smart enough to be here? Or what should be my goal here? If those are the kinds of issues that some people are having in a course, they are not necessarily going to use the offense very well. Because first of all, when you have anxiety about these kinds of issues, then what are the kinds of things that can happen? I want to ask people. Can you actually tell me, like, these anxiety or, concerns about these kinds of issues, how can it impact efficient problem solving, effective development of effective problem solving skills, transfer of learning from one context to the other, robust understanding of physics concepts and principles? Like, can anybody actually come up with some examples of what kinds of impact this kind of, not having these things straightened out by course instructors or mentors of student researchers, if you haven't really dealt with these kinds of issues, how can it impact those kinds of things? Any thoughts?
Negative impact on confidence.
Negative impact on confidence can lead to what?
Yeah, lack of motivation.
Inefficient problem solving? Okay. But, sorry, go ahead.
I think, if some students don't want to look dumb or feel dumb, they might not reach out for help when they need help and they're struggling in a course. So they might not go to office hours because they don't want the instructor to think they're stupid.
So very good. These are all good thoughts. So think about it. So I think what you guys said is a really good thing. So I want you to think about this. If a person is struggling with physics problem solving, they can have two completely orthogonal reactions to that, right? One reaction would be what you said. I am struggling with these things because I am not cut out to be here. I am stupid. I really don't belong here. I'm not good at it. What is the opposite? What is the orthogonal reaction to this that you can have when you're doing challenging problems? Please, Anjali?
The problem is too hard or it's badly set up.
Okay, that's an externalization, and that's a good thing too. The thing that I was, and we will come back to your thought also, Anjali. What I was saying is that the orthogonal reaction would be, yes, I am getting somewhere. This is great. Like, I got a challenging problem. Einstein himself said, if you have not struggled, you have not tried to learn anything new. Right? So struggling is the stepping stone to learning something new. And this is what we want students to know, that you need to embrace your challenges, you need to do challenging problems. That's a great thing, because that's the only way you learn something. If we weren't learning anything new, then it wouldn't be fun to be in physics. We are here because we really want to do difficult problems, challenging problems, problems that actually we don't know the answers to, because that's how you figure it out, after failing and then getting up and then failing again. But who are the people who are actually likely to actually collapse into this state as opposed to this? You are more likely to have underrepresented students who don't see other people around them collapsing into this state and thinking that the reason I'm struggling is because I'm not smart enough to be here, other people don't look like me, I'm not cut out to be in this place. So they will start having this self-efficacy issue, this issue related to belonging. On the other hand, other people who are more likely to be from majority groups will actually have this thing. I'm not saying everybody, because one thing that I want to say is that whatever is the best practices for underrepresented students is also best practice for everybody else too. That is one thing that everybody should realize. So something that is good for one group of students will actually be good for everybody, but the group that is most vulnerable is the one that is most likely to benefit from whatever interventions you do. Please.
Also, to do all the stuff on the offense side, you need working memory to be free of, and if you're instead worried about self-efficacy or your confidence or whether you belong there, then you're wasting valuable brain power on that.
So that's a really good point, Katrina, right? Yes. So very, very good point. So the point is that not only does not having your defenses straightened out, and notice that you as an instructor, you as a mentor, you as a research advisor play a key role in making sure that students have their defenses straight. What she said is also correct. So not only is it that the person who's actually having issues about self-efficacy, intelligence mindset, and sense of belonging, first of all, they are more likely to do task avoidance. They'll be like, oh, maybe I should be doing something else as opposed to doing something that I don't think I'm good at, right? So you're going to do less. The overall time on task will be less. Also, you will want to do less challenging problems when you should be doing challenging problems, because that's a really good way of learning. But also, when you actually engage with the thing, your working memory is constrained because you have only limited capacity of your working memory when you're trying to solve physics problems or any kind of problems. And that working memory, if some of it is being taken up by the anxiety of the situation, you're not going to be able to give all of your cognitive resources to the problem solving at hand, and that is also hurting you. So basically, you're basically triply getting hurt. Less time on task, not doing challenging problems, and when one engages with the problem solving, you're really taken up by anxiety is taking up some of the resources, cognitive resources, and that's not good either. So notice that these things are so intimately tied that it's really important for us as physics professors to think about not just this offense, but also the defense. Because if you don't think about the defense aspect of it, the students who are most likely to be hurt are going to be the ones who are from underrepresented group. But other people can be hurt too. So here is one thing that I want everybody to discuss with the person next to them about. It says, Professor Smith is concerned about the high failure rate in his introductory physics course. To encourage students to work harder, he first starts the class by telling students how difficult the course is and that usually 25% of the students fail. They must be careful, particularly if they think their background preparation is weak. I want you to discuss with the person next to you, why is it a bad thing to say in the first day of your class, even though you say it most cheerfully? All right, any thoughts from somebody over here? Can somebody from here actually say something about what they think might be the problem here? Please.
It already isolates students who already don't feel like they belong in this box where you do not belong, now get out of the box, which is putting more weight on the student and already pointing out the fact that they don't belong, even if it's subconscious, it makes it conscious.
Right.
It allows everything.
That's a really good point. And you can see that this kind of a thing is going to hurt those people most who are least privileged, right? Because the thing is, like if people came from a school where the infrastructure is bad, the best teachers are not available in those areas, AP physics is not available, those are the students who are likely to actually feel like, okay, I've already, like, what's the point of being here even, like, I mean, the instructor has already said, I must be in the bottom 25%. So you can see that this is immediately giving a signal to a lot of students that, it's really, they really don't belong there, and it's also giving this fixed mindset view. You want to actually promote growth mindset. This idea of growth mindset versus fixed mindset is really important for all of the instructors and all of the research mentors and advisors to inculcate, and basically the idea is that people's ability to solve challenging problems is not a fixed thing. It really depends upon how hard you work, how smart you work, how you actually tackle with challenging problems and think about them, right? And so you want to really promote that idea of growth mindset, but if you are saying, oh, 25% of this class is going to fail, then yeah, people who came with the lowest, background, like in terms of preparation, they are going to think, okay, I don't even belong here. Why did you even say that this course was actually, I had all the prerequisites for this course because I'm in the bottom 25%. So that's obviously not a very good thing to do. Here is another example. It says, Professor Jones wants all her students in the class to succeed, and she hopes to increase diversity. She schedules weekly help session for students who might be having difficulty, and she emphasizes that all the women and racial and ethnic minority students should attend, stating her past experience suggests that they are more likely to need this type of extra help. Please talk about why this kind of thing is not good either and what could be done better, please. Any thoughts, anybody?
I mean, it's basically a perfect example of stereotype threat. In some sense, you're just telling people that, if they belong to this group, they need extra help, so then they'll start to think that if they need extra help, they're not as good.
Yeah, that's a really good point, and it's good that you also introduced a word, stereotype threat. Stereotype threat refers to the kind of threat that a particular group feels, like when they feel like, because they belong to a particular group, they must actually, they start conforming to the stereotypes of that group. You feel like, oh my God, I'm a woman and women are not supposed to do well in this thing, or I am an underrepresented minority and they're not supposed to do well. And in this particular case, the person is calling out those groups and saying, oh, you must definitely come because you need help. So it's pointing out that those people somehow, it exacerbates this threat that these people already have, right? So it elevates it to the red level. If it was at the yellow level, it goes up to like super red. Right? So the point is that this kind of thing is not good, but what could one say? I mean, you can actually make these kinds of things open to everybody. If you are doing some kind of, extra help sessions, where people are doing tutorials or solving problems together, you can actually improve, the learning of everybody by actually inviting everybody to the class and not pointing out a particular group, which can actually exacerbate the stereotype threat. Here, please.
It's an aside, and it's not here or there, but I'm just curious about your impression. Do you think this is much worse than the previous slide? Equally worse? Slightly better? Or I mean, where are you?
I would not do either. So I mean, I would not do either, because the important and one of the important things here, whether you are talking about these kinds of things in class, whether you are actually adapting these kinds of things and thinking about mentoring students, again, there are lots of research studies that show that when you are actually mentoring students, it's really not that as a mentor you need to spend a lot of time. The time on mentoring is not a very good measure of how the student is really mentored. It's a matter of how good of an environment you set and how you actually promote, again, a supportive environment in which the student feels like tackling difficult problems, focusing on research and things like that. So neither of these things is good, because it's not really actually getting a particular group to feel good. A student asked Professor Rowe how to solve a physics homework problem. The professor immediately starts laughing and exclaims, "This problem is trivial." Please talk to a person next to you about why this is not a good thing to say. Why is this not a good thing to say? Please.
I mean, it just sort of, whether or not you find a problem trivial basically conveys your personal experience and background. Right. And so rather, you're sort of just telling the person that you personally don't see how someone else could not understand this problem, which is not really an act of teaching or helping anyone. It's just saying, like, this is my background, and you don't have this background, and I don't think that I even need to explain it to you.
That's
It makes it inaccessible.
That's good. And also, I mean, does everybody agree with the fact that this kind of thing is likely to negatively impact people from underrepresented groups more than majority groups in general? So, you know, we have done like more than 50 individual interviews, 1 hour long, with lots of women in physics. And guess what? We find that women in physics are much more likely to be impacted by these kinds of comments from professors or the TAs. You know, if they go with a problem and the problem says, oh, this is really trivial, you know, it really is interpreted by those women to mean that they are not smart enough, or they are asking a question that is dumb. You know, a majority group may not feel that way, and this gets back to this issue that Anjali was earlier mentioning, that, you know, I mean, sometimes what happens is that, you know, like, and there are research studies to also support this, that women oftentimes drop out of a particular discipline, even if they are getting B's in those things, as opposed to men who might be getting C's. You know, they think they are doing fine. And it has to do with this internalization versus externalization. If you think that you're not doing well in something, B is not a good grade because you were getting all A's in high school and this is a B here, that means that, you know, you are thinking, if you think that it's because of me, you know, it shows something about the fact that I'm not cut out to be there, that person is more likely to say, I am out of here, I'm going to major in something else. On the other hand, if suppose somebody says, oh, you know, it's because this course was, you know, like my teacher was not really good, he didn't teach well, or, you know, like this semester somehow I didn't work hard enough, you know, next time I'm going to work harder because this was a hard course and I just didn't put in the time. Those are external things. You know, they don't pertain to you not being good enough to do the thing. But it's something about you not working hard or the teacher not being good. Those and what research has shown, in fact, Elaine Seymour and Nancy Hewitt, they wrote this book about talking about leaving, why undergraduates leave STEM, and they had interviewed more than 350 students. Majority of them were women or other underrepresented racial and ethnic minority students, and majority of them were saying things like this, that they didn't feel that they were smart enough. They were always internalizing. It was their fault that they actually didn't succeed in physics or in other STEM disciplines, because they felt that they weren't doing well. It was not about the teacher not doing well or something like that. And you can see that minority students who have more stereotype threats, they are more likely to internalize and dismiss their own potential, because they can get caught up in these kinds of things and say, oh yeah, I can see that there are not very many women in physics, and, you know, I'm struggling, I should be out of here. I just don't belong here. And they are more likely to say, oh, if somebody is saying this problem is trivial, means I'm not smart enough to be here. In fact, I don't know how many of you actually read the New York Times op-ed by Eileen Pollock, who was the first woman to major at Yale University in physics. Anybody? This came out in 2013, and now she's written a full book. Anybody read that? So she talks about her experiences being the first woman in physics there, yeah, right, at Yale. And she says, you know, I actually did this, you know, theoretical project with a person because just like at Princeton, it's mandatory to actually do a research thesis as an undergraduate. And her advisor, you know, she presented it. Her advisor didn't even say anything about whether it was good, bad, anything. He just signed it. And she thought she had done really well in her mind because she had really put in the effort and she did the thing. He didn't say anything. He just signed it and gave it. And she got really very strange feeling about, you know, what was it? Like, did I do okay or did I not do okay, right? So the other thing that happened was she went to another person in the department who actually was supposed to advise her about doing PhD, and she said, you know, I'm thinking about going to do PhD, and guess where she wanted to come to do her PhD? Can you make a guess? Yeah, so she said, you know, I really want to go to Princeton to do my PhD. This is 70s, right? And the guys, the professor who was the advisor said, what? Do you know how hard it is to actually do a PhD at Princeton? And So she really internalized these two things. The fact that her own thesis advisor as an undergraduate did not say anything, he just signed the thing. She meant it to say it was a very mediocre thesis, it was not a good thesis. This is how she interpreted it. And also the fact that, this person said, oh, are you kidding me? You really want to go to Princeton? Now think about it. To give the benefit of doubt to this person, he might have said this to men too, right? He might be saying this kind of thing to men also who would say, oh, I want to do a PhD at Princeton. What did she do? Does anybody know what Eileen Pollock does now? She is an English professor at University of Michigan Ann Arbor. She did her graduate work not in physics. She got out of the discipline. She went and she became an English professor. She did her graduate work in English. So now she's a professor at University of Michigan. And so when she was writing this book, she came back to Yale, and it turns out that since her advisor was a young person, he was still a professor there. So this time she is like 30 years later, she's much more confident, and she says, oh, can we actually have breakfast together? And so she had breakfast, and this person said, this time since she's so much more mature, she's like, what did you think about my thesis, my undergraduate thesis? And he said, you know what he said? Does anybody, who has read the article? So what did he say?
He said, oh, I remember your project, and it
was the best ever. It was like nobody has done such a good work. And she said, why didn't you tell me that then? Because again, the ambiguity, the fact that this person didn't say anything, it doesn't matter so much to a person who's from majority group. If 80% of the people in physics are men, if you don't praise them for their work, it doesn't really actually necessarily say that you don't belong here or you didn't do a good job. But if you don't say this to women or other racial and ethnic minorities, they will interpret it, or you saying that something is trivial or it's too hard to get a PhD from Princeton University, they interpret it to mean I am not cut out to be at Princeton, to do a PhD. So, they internalize the message to mean something only for them, even though it may be some really general comment that doesn't even mean much to a general person who's not from the underrepresented group. So it's really important not to say these kinds of things. So this idea of stereotype threat has already been brought out. This is the fear of conforming to a negative stereotype about oneself. And the point is that awareness of the stereotype is really taxing, and it takes cognitive resources and hurts the performance of the person who's in this particular group. So for example, if somebody is struggling, they would say, oh, that means I'm not as good as other people. And you can see that underrepresented people are much more likely to be in this particular group. and you actually can do things to actually reduce these kinds of threats, as opposed to increasing the threats. And those three examples that I gave you, they were examples in which it would increase as opposed to decrease. Also notice, by the way, self-efficacy, a term that I am using probably and have not defined, it means belief in one's capability to succeed in a particular task. And again, it is really important to make sure that your students have high self-efficacy, whether they are research students, undergraduates or graduate students working in your lab or in your classes, introductory physics or any course for that matter. Because it can impact students' persistence, engagement, and whether they are actually going to persist when they are trying to solve difficult problems and when they are struggling or not, because they'll only persist if they have high self-efficacy. And notice the other thing that I'm saying to you is that anytime you have a situation where there is ambiguity and uncertainty, that actually leads to people relying on stereotypes, and it leads to the diminished performance of people and lower sense of self-efficacy and belonging and, this fixed intelligence mindset. So the point is that the reason underrepresented groups are likely to actually go into these kinds of modes, and you can see that this is what happened to Eileen Pollock, for example, and she completely decided, forget about Princeton PhD, I might as well just get a graduate degree in English. She thought this ambiguous situation meant that, she was not cut out to do this. Her advisor with whom she had done undergraduate research already didn't say anything when she had thought from her own standards that she had done well. she went into this negative thing and she thought, okay, I'm not cut out to do physics, let me do something else. And this happens to students in classes, this happens to students in research situations, in labs, and you really have to actually think about these issues explicitly, because you're not just trying to help students with the offense, you should be thinking about their defenses also. And small gestures and thinking can go a long way. So it's not a matter of how much time do I have to spend on this. So before I talk about my own research study, I actually wanted to first talk about a research study of Carol Dweck that many of you have heard of. She's from Stanford University, and she's done a lot of studies on intelligence mindset and how it really makes a difference. So let me show you this graph here, and in this particular case, the important thing is like two of the things, that the one that is going up and down, and this is in a math classroom in high school in which the same instructor is teaching two different courses. The only thing that this instructor does differently in the two classes is that when the instructor gives weekly quizzes or any exams and things back, the instructor would say, oh, John, you must be really smart, you got 10 out of 10. Oh, Jason, because Jason didn't do well, but it kind of made it apparent that the instructor meant that if somebody was doing well, they were smart, so as though it was a fixed thing, and when they didn't do well, then they were not smart, because if you give it like that, then that's what you mean. In the other course, the same instructor, the thing that he did different was he would say, John, you must have worked really hard, and then Jason, I really have high expectations of you, I know you can do it, but this time it looks like you didn't work hard. I want to see better performance, you work harder next time. I know you can do it, right? And if you need help, I'm there. What you can see is that in the beginning, trial 1 means that's at the beginning of the course. So at the beginning of the course, you can see that there is no statistics, and there was a third class that the person was teaching in which the person gave no feedback when the person was returning, the same person was, when they were returning the thing, no feedback. They were literally quiet when they were giving the things back every time students' work was returned. And you can see that at the beginning of the course, there is no difference between these people's math performance. This is in the context of math, high school math, right? But at the end of the course, the same exam, same math exam, you can see that the students who were in the class in which the instructor was always saying, I have high expectations of you, I know you can do it, you need to work harder, you need to do more challenging problems. That class, students did really well. The class in which intelligence was emphasized and fixed mindset was emphasized, as though John was really smart and Jason was not, students tanked. In fact, in that class, every time the instructor would say, let's do a hard problem, there would be chill. Students didn't want to do hard problems in that class, because it kind of like they felt that if they would fail with this at this problem, it would show that they're not smart, because the instructor was saying, oh, you are smart and you're not. On the other hand, in the other class, students were asking for more challenging problems because they knew that doing challenging problems is what makes you smart. So it's actually something that, intelligence is something that you can grow, because it's really a muscle. Your brain is a muscle that grows when you work hard. So this is a study that Carol Dweck had done like 20 years ago, but I think that this is still a classic study, and our study is actually based upon the same kind of thing. So now I want to actually first show you some data from our research. This is data on people's self-efficacy about how good they are at physics. And this is from University of Pittsburgh for thousands and thousands of students. And if you look at students in introductory courses, this is basically over a 1-year period, and we just published it in Physical Review, Physics Education Research. So anybody interested in the full thing, should go and take a look. But the point is, you can see that women have significantly lower self-efficacy than men about how good they are at physics. So the questions are like this: I'm often able to help my classmates, or I get a sinking feeling when I think of trying to tackle difficult problems. If I wanted to, I could be good at doing physics research. If I study, I'll do well in physics tests and stuff like that. And you can see that there is a huge self-efficacy difference. And if anything, the thing is dropping at the end of physics 2 as opposed to improving. So, and this effect size is not necessarily looking good. Now, the other thing is this mindset that I talked about, does working hard, working smart, and doing challenging problems actually make your brain grow or not, right? So what I want to also say is that, let me now actually go to the intervention that we did and what we did in that intervention. So it's a very short intervention, and you can do in any of your classes, and this is based upon, again, the kinds of things that Carol Dweck has done a lot at the high school level. I gave just one example, but this is a very common one. So in this intervention, basically somebody will go to a particular recitation class in introductory physics and say, hi, we are from the physics department, and physics department wants to know about, it's only 25 minutes at the most. It takes between 20 to 25 minutes, right? The first recitation class. We are from the physics department. The physics department wants to know your concerns that you have about being there. And notice that introductory physics students are also freshmen, at least at University of Pittsburgh. So basically, everybody is handed out a piece of paper. Can you write down what concerns you have about being in this physics course, right? And people write a lot. They'll say, I have a pretty, like, for example, women often wrote even worse things than men. If you look on average at what kinds of things people write, I have a pretty low self-confidence when I see how other people are so smart, other people understand more than I do about what's going on. I feel like I have to work a lot harder. For physics, I feel like I don't connect things well enough. I don't feel comfortable in this class. Physics gives me a sinking feeling. It kind of scares me. By the way, the other thing that I would like to say is that I did some of the interviews with women, and it's really interesting because somehow in our discipline, more than any other discipline, we have given to these women such, negative ideas about whether they belong there or not. So for example, I was interviewing this particular woman who said, oh, I love physical chemistry. I absolutely love it. And I said, do you realize that physical chemistry is almost physics? And she's like, no. We do Schrodinger equation, and we are doing things like, we are doing vibrational mode and rotational modes of, it's like, really? That stuff is not physics, And she's like, is it possible? People tell me, Lexi, you're not supposed to like physical chemistry because, it's hard. But for me, it's not hard because I really love it. Can you love final exam? I really am looking forward to the final exam in this course. So this person, every time I would tell her that physical chemistry is almost like physics, she would give this hysterical laugh as though, I was saying to her that was something that was totally different because she was doing Schrodinger equation there and physics was like, Newton's laws or something like that, So it was a completely different thing for her. But you can see the kinds of things that people are actually saying and the kind of environment that we give that everybody needs to be brilliant like Einstein in order to be in this discipline actually makes people have these stereotype threats even before they have come to that class. Please.
Do you think part of this is maybe because the way that intro physics introduces like a series of puzzles? And like chemistry, my high school didn't really have physics, so I only took chemistry. And chemistry sort of introduced kind of this taxonomy, and there are these just sort of random things you kind of have to memorize, but it feels like anybody can memorize the names of these molecules or what orbitals mean before you even know what orbitals mean. But physics is there's all kinds of trick problems, all your intuitions are yanked out from under you the moment you get introduced to, oh, momentum is not what you thought momentum meant and all this stuff. And so it sort of leads itself to puzzle solving versus sort of a gentle entry or something.
So, I will have to give you something that is a hypothesis of mine. So my hypothesis is something similar to yours, right? So one of the things in physics that we actually do a lot, and this is related to another study that was done by Tim McKay at University of Michigan, which is that, in physics, it's true that oftentimes we actually, for example, if I would do a problem with ballerina putting her arms close to herself and putting her arms out and talk about, why she would spin faster or slower, and how it's related to angular momentum conservation, on the exam, the problem will be about neutron star is collapsing under its own gravitational force, right? And, it was rotating at some really slow speed. And what happens to the speed of the neutron star after the radius goes from this to this, right? The point is that in a situation in which you actually don't feel prepared and you need to think on your feet, like in this situation? Because notice that changing the context now makes it completely new for students. So for you, it's like the same problem. A professor might even say to another student, I don't understand why my class bombed on this problem, because it's exactly the same as the problem that I had done in class. But it's not exactly the same because you change the context. And in fact, many students are saying, why are you giving me this astrophysics problem in, introductory mechanics, right? But the point is that stereotype threats are much more salient in situations where you throw a novel problem at people and they have to do it in a fixed amount of time. In fact, at University of Michigan, Tim McKay did a study in which they have like 2,000 multiple choice question database for introductory physics, and they let students practice those problems for introductory physics at their own time. And they keep track of the gender of the students or who did it, right? And every time you click on something, it'll say whether you were right or whether the answers were wrong. And guess what? Women and men, actually, there is no statistically significant difference between how men and women do. If anything, women do slightly better on the practice thing, right? But in the exams, women are doing significantly worse than men. Like these are timed exams, like, 2 hour to 1 hour, 50-minute exams. And so the question is, why is it that at their own time, if anything, women are doing slightly better on these things? And they have data from like literally thousands of students. So these are really statistically significant results. But that's not the case when you do it under time constraints. So in a way, what you're saying, I agree with it, that in physics, like the fact that, the context changes and you have to do it in a short amount of time, I mean, it really does create a stereotype threat for people more when you don't feel like you belong in this discipline and when you don't really look at the struggle as being a positive thing. If you go into this mode where you feel like, oh, I am struggling with it because I'm not smart enough to actually answer this question or be in this class, you're not going to relax and think about that. And that's the kind of thing that happens in physics much more than chemistry. So
precisely because physics is universal and we expect it to be applied to a wide variety of contexts which students might not appreciate at the very beginning, as opposed to chemistry, where it's sort of all in.
And we are not even doing a very good job of helping students actually apply the same concept to different contexts. If we were doing a good job of actually helping students see why a ballerina problem and a neutron star problem and a person driving from the diving board who wanted to do many more somersaults should be tucking their body in, how all of these problems are really in the same universality class, then in that case, students would feel much more comfortable. So we don't really do a good job. Oftentimes we are not thinking about the difficulty of the problem from the student's perspective. We are thinking about these are trivial problems. They do ballerina, they would figure out neutron star and person making a lot of somersaults because it's exactly the same. To you it's the same, but not to the students, right? So if we were doing a good job of helping students see how these things applied across different contexts, that would really help a lot. But what I'm saying is that the stereotyped group has more threat in these situations where you're throwing problems that don't look like anything that they've seen. It's like if I were giving a talk and if I were really nervous about my performance in that talk, if I practice ahead of time 30 times, there is a good chance that even if I were nervous, you wouldn't know that I'm nervous, because I would do a perfect performance because I've practiced 30 times. In physics, you don't necessarily get that if the problem looks totally new. But that wouldn't necessarily even be the case. I remember I started out by saying that even in Calculus 3, what we find is that women are actually doing 1 grade point average above men. Remember I told you that you will see that if men have an average of 3, women will have something like 3.3 or 3.25 average, right? Calculus 3 is like really vector calculus. You need to do 2D, 3D integrals. Even at those, women are much better than men. You might say, oh, it doesn't have anything. A lot of people have postulated, oh, it's visual ability and this and that. No, those 2D, 3D integrals, you have to actually really think about what's the right, should I be doing the z integral, y integral, x integral, what should I write for the equation? But the thing is, even those kinds of situations, you can still plan out ahead of time and think about those problems as a class of problems in a systematic way before you go to the exam and do it, as opposed to in physics, we suddenly throw something which looks trivial to us and it looks exactly it may be isomorphic, But it's not really the same problem for the students if we haven't done a good job of explaining to students what those things are. And what I'm trying to say is that stereotype group is much more likely to feel threatened by those kinds of things and have difficulty, go into this panic mode. Is that what you were saying too?
Yeah.
Okay. So anyway, so these are the kinds of things people are saying. So the question is, what can we do? So these are the kinds of things people wrote when we told them to write. And in 5 minutes we had to say, stop writing, you're done. And people literally wrote like pages. In 5 minutes people just kept writing. Okay, then the second thing they were told was, look at all these things that past students have said about how they have succeeded in physics. And then we had like 5 quotes from students. Some of them were female names, some of them were male names, some of them were names that looked like they were underrepresented students. And basically everybody is saying the same thing. So everybody was saying things like, I came to this physics class and I thought I was really worried about being there. I didn't feel like, I would do well. But then I realized that I should be working hard, I should be working smart, I should be proud of doing challenging problems. And then I started taking advantage of my peers and my instructors and TAs, and I started doing hard problems. And lo and behold, I really did well in the physics. I was really happy about the fact in the end, everything worked out so well. And so everybody's saying it in their own language, but all these students are talking about their success stories in physics, and they're talking about how they were worried, but by working hard, working smart, doing challenging problems, and embracing their challenges as learning opportunity and being proud of it, they really actually ended up doing well in physics. And then after this is 5 minutes, like five quotes are shown to them. Then they're told for 5 minutes, okay, make groups of 5 and talk to each other about what you wrote in these sheets, on that sheet. So everybody starts talking to other students in groups of 5, and guess what they find? This ambiguity factor is removed. Except for a few people in that class, most people, men or women, they all say, I'm worried about being in this class. I'm not sure, how it's going to go. I'm kind of worried. So people start realizing that it's not only me who's worried about being in this class, a lot of people are worried about being in this class. And so it brings down this, I'm not the only one who's being told that Princeton PhD is going to be hard. Everybody is going to be told the same thing, or everybody should be thinking. So that kind of normalizes this thing and reduces the ambiguity. And the last thing that you do in this kind of Carol Dweck, Claude Steele kind of intervention is you tell students to take the last 5 minutes in writing a 1 or 2 paragraph letter to a future student telling them how they will succeed in this physics course. Notice that this is the first week of classes for those students themselves, right? But when you externalize it for somebody else on a piece of paper, it's like saying something is believing, right? So now in some sense you're telling them, what have you learned from what we just did in the last 15 minutes? Can you actually put it down so that for a future student? And so it's like they're doing it for themselves, but they all again write about how they would succeed in this physics course. So a lot of them will write, you have to work hard, you have to work smart, do challenging problems, feel good about it, feel proud of it, and stuff like that. And the idea again is that by reducing anxiety, if you actually make sure that people understand that a lot of people are having similar kinds of concerns about being here, and that a lot of students did well in the past by actually working hard and working smart and embracing their challenges as a learning opportunity. That can reduce anxiety, that can reduce procrastination, increase enthusiasm for solving challenging problems, and ensure that their limited cognitive resources, this working memory, is used for problem solving and is not robbed by the anxiety, right? So I already explained to you what the intervention was. So this is the activity message. Yeah, and then this writing exercise. And people have written a lot of very interesting things. I'm extremely worried that I have wrongly overcalculated my mental abilities by ending up in engineering program. Notice that a lot of these people in introductory physics are also engineering majors actually. And so this is the beginning thing that they write, but then when you show them all those quotes from past students who have succeeded and have them talk to each other, it brings down their anxiety, and then they write that essay at the end. Yeah, this is one example of what one student, Ellison, said about how she succeeded in physics. I mean, if anybody is interested, I can send my slides to Malika and she can, distribute it. But in the end, by the way, I have to say one thing. When people went as physics department representatives wanting to know about how the physics department can help students in that class, what their concerns were, at the end of this 25-minute intervention, the whole thing takes 20 to 25 minutes, in many of the recitations, students clapped for them. Many a times women actually especially came to the people and said, thank you so much for coming. I feel so much better. It has brought down my anxiety. So they explicitly said that, right? If that was the end of the story and it didn't impact people's grades or anything, I would still say you should still do it. Maybe the impact will not show up in the grades for that semester, right? Guess what? And by the way, we didn't go to all the recitations because we went to only half of them because we wanted to see whether this thing will make a difference. And what you see is that the performance of men and women is pretty much equal in the control, in the social belonging group as opposed to in the control group. And we had given some math self-efficacy survey also. And what we found is that students who benefited the most were the ones who were feeling the largest threat. So in other words, the ones who actually were thinking that they were not going to do well in math in this course, even though, as I said, on average, women are actually doing better in math than men, like if you look at the average score on math. But those are the ones who benefited the most. So the point here is that a short activity that focuses on belonging and mindset can reduce the gender gap in performance. And now we are actually doing studies with TAs themselves, and we are going to look at long-term effects of these things. Because, by the way, Carol Dweck studies and all have shown that 8 years later and 9 years later, people are still actually benefiting from the kinds of interventions that they had done in high school. So actually, I mean, these kinds of things that people, are exposed to, and that's really true. The point is that you shouldn't be thinking that struggling means you're stupid. People should be collapsing into this state that yes, I am getting somewhere. This is the only way to learn something new. Like you should be struggling with challenging problems. So you are saying to them all the right things, but it's important for them to hear it from somebody who's the authority, like you, the instructor, because then they'll believe you. That yes, I should be working challenging problems. I should be, embracing my struggles. The other thing is that similar issues also are there in research labs. So in research labs, underrepresented students, again, are not necessarily likely to feel like they belong there unless you, as the research mentor, actually sets a norm for the group where everybody feels like they belong there, everybody has the self-efficacy to do well, everybody's work is actually praised. You have to, especially if you don't praise people's work, underrepresented people are the ones who are going to go into this ambiguity mode where they are going to think they're not doing well. So it's really important to actually praise them. And also, you need to really mentor students also in these kinds of things where they understand that research never goes linearly like this. And again, underrepresented students are more likely to feel like if the research advisor doesn't make it clear that, oh, it's okay to, so long as there is a drift, you're going to move back front, that's the way research is going to go. It's never a linear path. Majority groups are more likely to think it's okay, and minority groups are more likely to think, I'm not doing a good job here, or something has gone wrong. But just like making a supportive a supportive environment where you as a mentor set the norms for how the group is going to work and how people should be working with each other is really important. The other thing that I wanted to say, and this is also a paper in Physical Review, Physics Education Research, if anybody is interested in taking a look at this also, we did another study in which we gave to students at the beginning of the course, Introductory Physics, we gave to them Force Concept Inventory and Conceptual Survey of Electricity and Magnetism. These are standardized tests that are out there that you can give to students at the beginning of the course, and they can actually give you some idea about what the students know about these laws of physics at the beginning. And you can just tell them that, you just do it the way that whatever thoughts come to your mind, it's not going to be graded for correctness. Maybe you can just, have them do it sincerely. But the point is what we found, and there were some questions like this about intelligence mindset there, so one question was, men in this course are more likely to do better than women in this course, right? And we looked at the performance of women who actually agreed with this fixed mindset thing versus who didn't agree with it, right? You can say agree or strongly agree, disagree, neutral, and things like that. And at the beginning of the course, there was no difference in the performance of women on FCI or CSEM, depending upon whether it was Physics 1 or Physics 2, right? Guess what happened at the end of the course? Any guesses? Please, Katrina.
Oh, I wasn't raising my hand.
Oh, okay. So basically, the group that actually, the women who said that they disagreed with this fixed mindset thing, they did significantly better than the women who didn't agree with this, right? So you can see that one semester, 4 months can make a difference. Somehow these people came with very similar background because initially there is no difference in their score on these kinds of conceptual survey. At the end of the course, the group that has growth mindset is doing significantly better than the one has that fixed mindset. By the way, this is not the same class in which these interventions happened, okay? So you can see that and again, those cognitive mechanisms that I was talking about earlier, which is that if you have fixed mindset, you have more anxieties, you're more likely to procrastinate, you're more likely not to do challenging problems, which you should be doing, you're more likely to have fear of failure, you're more likely to, when you are actually engaging with something right before the exam, you're more likely to, have these anxieties that are robbing some of your cognitive resources so that you're not really giving it, full effort to the task at hand, right? So the point is that it's really important for us as instructors and as people who are in the position of making this thing to make sure that we focus on the defenses, because defenses are really important for women and other underrepresented students. So even though you may say, I'm a physics professor, I only focus on problem solving and reasoning skills and this and that. No, you need to also worry about these things, and short amount of time getting these things straight can go a long way in helping these students and make sure that physics gets diversified, because a lot of times these kinds of problems are there and we are not really thinking that it's also our job to do something. And it's not even that it's requiring a lot of your time, it just requires that you actually are thoughtful. You don't say, 25% of the class is going to fail. That actually is a fixed mindset thing. You shouldn't be saying problems are trivial when somebody is asking you a question. Those kinds of things actually go in the wrong direction. They put people in a feedback loop that's going to get them down even further, right, along the path that they actually are already more susceptible to be in, right? So because of the fact that we have all these stereotypes about, who should be in physics. Just looking at the thing, you can actually say that stereotypes are definitely there. Please.
So I have a question as to whether or not there's a set of best practices when actually designing the assessment. So
assessment means what?
Like an exam, right? And not just for an introductory class, but also for, let's say, more advanced upperclassmen or graduate students. Is there a set of best practices for designing an exam that would help to mitigate these issues? Like, for example, if it was take-home exams better than not take-home exams, or should we not be giving these kinds of problems where it's
so that's a really good point, and that's related to some extent your question earlier, right? I mean, these two issues are kind of related, because remember I was telling you earlier, and again I'm going to hypothesize something because this is not my research right now. So based upon what I've seen in the research studies, like for example, University of Michigan, I already said that there was no statistically significant difference when they were doing it at home, and they have thousands and thousands of students' data. If anything, women were doing slightly better. On the other hand, on the exam, it works the other way if you have timed exam, right? So first of all, what do you mean about what kind of exam? First of all, it also depends upon what you did in the class itself, right? I mean, how much time did you give students to transfer their learning to new situations so that they actually saw the connection between ballerina and neutron star and something else, because otherwise if you were just thinking in your mind, because you're not putting yourself in your student's shoes, you're just putting you're thinking, if I understand something, if something is trivial for me, it's trivial for my students, and you're thinking that neutron star and ballerina are the same problem, then yes, people who are actually already have certain stereotype threats going into the exam, it's going to heighten even more when you give them ballerina that they have never, the neutron star, when they've never seen it before, because this is a totally new situation. It's like, oh, I'm the only one who actually doesn't know how to do this thing, and they go into this negative loop. So I think that, how you teach can make a huge difference here too. But then again, this timed exam versus untimed exam. So one of the things that University of Michigan is doing after this study is that they have decided that in all of their physics courses, if the test is a 2-hour test, they'll actually allocate, like, let's say 4 hours. So all the faculty at University of Michigan have agreed that they are now going to give extra time to people just so that, because when people are really under stereotype threats and they're thinking, oh my God, I must be the only person who doesn't know how to do neutron star. What does this person have to do with mechanics? This problem have to do with mechanics. If you take more time to think about it and calm down, you might still be able to do it. So their hypothesis is maybe giving extra time would help. Right? So that's why. Now, should it be take home or what should it be? The point is that generally, at least this is my own experience, the take home exams, that, every time I had take home exams, they were much harder problems than the other things. So, personally, I don't know if you give the same kind of exam that it really would necessarily help to give a take-home exam. Now, I definitely would say that in homework, you should be giving much harder problems. And again, framing it for the students is really important too. So saying to students, what is the goal of being here? Why are we here in this class? If I just gave all of you A, will you not even bother learning any physics? If that was the case, then we really are wasting our time, right? So how is it that taking this physics course is helping you with your problem-solving skills, your reasoning skills, your metacognitive skills? After your undergraduate major, you may not even become a physics major, but that's fine. But some of these skills that you're going to learn will become your own, right? And so having this kind of framing and doing this thing that do challenging problems, think about it, and it's really going to make you better problem solver. It will help your brain muscle grow, and you will become much better at doing these kinds of things. I think that framing it in that way and giving them, some problems in the homework, part of the homework problems being challenging, is a good thing, because that you can even have a couple of problems that students can work in groups of 2 or 3, right? In the homework, that's a good thing. Giving some exams, which are, say, individual exam, and then maybe following it and saying, oh, 10% of the thing or 20% of the thing will be on group kind of thing. That could be a good thing to do too. But I do agree that, there is a lot of discussion about should giving a totally new problem, that is completely novel in the exam situation in which certain groups are feeling even more stereotype threat than other people, is that a logical thing when you haven't really prepared students by actually doing in your class things that will help them transfer their learning to new situation, from ballerina to neutron star to somebody making somersaults from a diving board. There needs to be effort on our part to teach students to do that kind of transfer before we actually feel comfortable giving another problem like that will completely throw students off, because certain groups are more likely to get worried about that than other ones. So again, as I said, there isn't any research finding on it, but based upon whatever is out there, this would be the suggestion that I would give to you. I also wanted to say another thing, like somebody was mentioning something about active learning, and that, you get students to work with another student. We have another paper that was also in Physical Review, Physics Education Research. And if you're interested, you can email me and I'll send you the paper too. So in which what we see is that if you have, like Eric Mazur at Harvard University, he's done studies in which he shows that doing a lot of peer instruction with clickers and things like that reduces gender gap. But that's not always the case. So the point is, what we find is that if the instructors are not taking into account the kinds of things that we are actually telling you, collaborative environment is another situation in which stereotype threats can actually increase as opposed to decrease. Just like, like throwing a new problem can do this. Collaborative situation where some people are showing off, some people are saying, oh, this is trivial, I took AP Physics, everything, like, I already know everything. Other people might feel like, oh my God, I'm the only one who doesn't know. And when you are just like, so in a class, which is just lecture-based class where the only interaction is between you and instructor, nobody even knows who other people are, as opposed to, a class in which you're actually having students work with other students. If you don't do the kinds of things that I'm telling you to do and create an inclusive environment where everybody knows that, yes, I should be proud of struggling, I should be proud of doing challenging problems, failure is a good thing, because that's how you get up, and then you run again, and then you try, and you learn new things, and your brain can grow that way. I mean, if you don't actually create the right kind of environment, what we see in our own study is that gender gap actually increases in active learning classes as opposed to decreases. So you can see that creating these kinds of inclusive environments where you actually get people to have good defenses is a really important thing. So just saying, oh, I'll throw students in groups and have them work with each other, it's not necessarily going to have underrepresented group necessarily benefit as much as majority students would.
I'm kind of wondering how you were able to, I guess, prevent these like show-off types from taking the stage when you had this like event where everyone was like, like writing like why, or writing about like your anxieties about taking this class. How in that environment were you able to like prevent people from just saying like, oh, I have no worries, I'm gonna do.
So I don't think that there is nobody like that. So maybe like that there were 10% of the people who actually did even write that oh, I'm good with this course, like, so everything makes sense to me. I'm just taking it to improve my, to keep my GPA up, because I've already taken this in high school, but I'm just trying to boost my own GPA. So there were like 10% of the people like that, but majority of the people were not like that. So majority of the people have similar kinds of concerns. So there's nothing you can do but about those kinds of people. But notice that you are giving a message independent of the fact that 10% of the people are like that, right? So your message is a separate message, which is saying, be proud of struggling. You want them to collapse into this state where they're feeling good. Yes, I must be doing challenging problems. My brain is growing. I'm getting better at physics, right? And that's what you want them to do, as opposed to collapse into this state where, oh, I am stupid, I'm struggling because, I'm not good at it, like I'm not cut out to be here. You don't want that to happen. And so I think that you're giving a message, and all those other things that you show from the students who have really succeeded in the course, they also show the same kind of thing. So the point is that you are giving this message about belonging, you're giving this message about self-efficacy and mindset, intelligence mindset, the combined message that is independent of some people showing off. So you can't actually do anything about those, but they are actually minorities. So most of the men also say, yeah, I'm kind of worried about being in this physics course. Although, the comments from women are the ones that are more stark.
Well, you can always discuss with them if that's happening in your class and explain to them why this is a negative contribution. You said there's nothing you can do about those people. They exist, but there are things you can do about them.
I mean, it's hard to find, it's very difficult to actually go to some people and say, you shouldn't be saying this or you shouldn't be saying that. And again, there is this thing about, if you can actually do it in a way that doesn't really hurt other people, then that's fine. Yeah, but notice that if you somehow single out a particular group, like remember that example that I gave in which this professor was saying, I particularly want women and underrepresented students to attend these extra help sessions because they are more likely to need help. Again, if you announce in the class that there are some people here who may have taken AP Physics and so they must be, definitely doing much better than everybody else, and so I don't want you to show off, it's not clear to me what impact that is going to happen on the rest of the class. You see what I'm saying? So if it was easy to figure out who these people are and kind of have a discussion with them so that it doesn't really actually necessarily create any kind of negative impact, then that's fine. I'm just saying that I don't think that there are any research studies where anything has been said to these people. So yeah, if you do it carefully and if you do it in a way that it doesn't really hurt anybody, because you can see that that particular comment where some professor had said that, it seems like it may be an innocuous comment, right? But again, a lot of innocuous comments actually turn out to be negative comments, including, oh, you want to do PhD at Princeton? Are you crazy? I mean, like, it sounds like, you know, you could say this to anybody, but the thing is, it doesn't really mean that you really meant anything negative, but some people take it more negatively than other people. So I think that sometimes I don't know how to actually identify those people and how you would actually approach them. It needs to be done in a careful way, if at all, if it's necessary to do this. So, I mean, regardless of the presence of such people, I mean, I would say definitely create a positive mindset environment. Definitely have students understand that you have high expectations of them. You know that if they work hard, if they do challenging problems, if they fail and get up and keep going, they will succeed. They should be taking advantage of their peers. They should be taking advantage of their TAs. They should be taking advantage of all the resources. And that's the way to do well in physics.
So you're saying that in your research you haven't found this to be a significant factor? The negative person who...
No.
Because we've heard in our community that in fact there has been impact. I mean, I don't know.
But notice that, you know, like in the study that I am talking about, you know, because I talked about two different studies, right? I mean, in one study I'm saying that, you know, if you just put students to work in groups and you don't do any intervention of this type, I'm saying that you see that the gender gap increases, right? So what I mean is that women don't benefit as much as men do in these situations. So that's one thing that kind of is related, you know, because some of those kinds of things could be going on. But notice that the stuff that I was talking about here is a different kind of thing in which you are saying, I am from the physics department and physics department wants to know about your concerns about being in this course, you know, like, and we want to make sure that you understand that the only way to learn physics is by struggling and by feeling good, and we are here to help. The more you take advantage of your peers, the more you take advantage of TAs and instructor, and the more you struggle, the more you do challenging, that feel proud, pat yourself on the back, because struggling and failing is the only way to learn physics. So you are trying to actually send a message, regardless of the fact that 10% of the people might be, you know, in the other category. So I'm just saying that you need to think about what the situation is, and you can see that the two results that I talked about, they were in two different situations. Yeah. Other questions?
I think with that, can we thank the speaker now? And
well, thank you. Thanks. Well, and I hope that this conversation, you know, like continues, because, you know, for me at least, I think that it's really important that we think about these issues, because I think that physics departments have focused on offense for too long and not on the defense. And the point is that you don't even have to spend that much time. It's just that you need to be conscientious. You need to actually make sure that you realize that any kind of ambiguous situation really actually could hurt certain groups of students much more than other ones. You need to instill the right kind of mindset, the right kind of, you know, and also, you know, praise them when they are doing well, because, you know, otherwise there is also ambiguity when you don't. Thank you.